Example 8. Suppose that f of x and g of x are differentiable functions such that f of 5 is 1, f prime of 5 is 2, g of 5 is 6, and g prime of 5 is 7. Find h prime of 5, where h of x is f of x divided by g of x. Well, h prime of x is going to be the quotient rule. So we start with the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, and all of that is divided by the denominator squared. So h prime of 5 is going to be the denominator at 5 times the derivative of the numerator, so f prime of 5, minus the numerator at 5 times the derivative of the denominator at 5. And again, all of that over the denominator at 5 squared. So we have g of 5 is 6, so that's 6 times f prime of 5 is 2, so that's times 2, minus f of 5 is 1, times g prime of 5, which is 7, and that's going to be divided by the original denominator, that's g of 5 squared. So that's going to be 6 squared. So it's 12 minus 7 divided by 36. So the answer is 5 over 36. Example number 9. Find an equation of the line tangent to the graph of f of x equals 5x minus 4 times x plus 6 at 1, 7. Now f of x is made up of two functions, so first times second. So f prime of x is the product rule, and yes, you could foil that out, but if you do and you don't get practice with the product rule, it's going to hurt you later. So do the product rule. It's the first times the derivative of the second plus the second times the derivative of the first. So f prime of x is the first, 5x minus 4, times the derivative of the second is 1, plus the second, x plus 6, times the derivative of the first, 5. So I'm calling this the first, this is second. So f prime is 5 and s prime is 1. So first derivative of the second plus second derivative of the first. So that's 5x minus 4 plus 5x plus 30. So 10x plus 26 is the slope of the tangent. Remember, f prime of x, the derivative is the slope of the tangent, and this is at any x value. Now they gave us a point, xy is 1, 7. So that's x is 1, y is 7, and our slope is going to be 10 times 1 plus 26, so our slope is going to be 36. Because we have to use the x point that they gave us, which was 1, and we use it in our slope formula, and that's how I got the slope of 36. So now we can use either y equals mx plus b, or y minus y1 equals m x minus x1. When I look at the format of what they want, they don't specify here, okay? It doesn't say y equals or slope-intercept form, so either one of these will be acceptable. So y is 7, m is 36, x is 1, plus b. So 7 is 36 plus b. Subtract 36. Negative 29 is our b value, so y equals 36x minus 29. That's an acceptable answer. If you use the second one, y minus 7 equals 36x minus 1, this should also be an acceptable answer, because if you clean this up, y minus 7 is 36x minus 36, add 7, and you'll notice y equals 36x minus 29 is the same answer we got there. So either the slope-intercept form or the point-slope form, either of those is acceptable unless they tell you to solve it for y. Sometimes they do, sometimes they don't. Number 10. The total cost in hundreds of dollars to produce X units of perfume is C of X equals 3X minus 7 divided by 5X plus 6. Find the average cost function. Find the marginal average cost function. Find the average cost and the marginal cost for production of 20 units. Interpret your results. Now, first of all, let's talk about average cost. If you sell 10 CDs for $100, then your average cost was 100 divided by 10, or $10 per CD. So it's cost divided by units. So since we know the total cost is this, the average cost has a bar over it. This is how we indicate average cost. And C bar of X is the cost function divided by X. So we have to take 3X minus 7 and put a divided by X in the denominator. Now let me show you why it ends up like that. If I take C of X, which is 3X minus 7 over 5X plus 6, and I divide it by X, doing it this way, divided by X, well, the rule for fractions is that you invert the second fraction, which in this case happens to be x over 1, so you change it to times 1 over x, and look where the x ends up. 3x minus 7, and then x times 5x plus 6. So it doesn't matter if you put the x in the front or the back, but when you divide a fraction by basically a whole number x, you just put that x in the denominator of the original fraction. So that's our average cost function. So that's the answer to part A. Now, the marginal average cost function is the derivative of this. Okay, so remember we've got C bar of X, and it's a quotient rule, but look, there's a product in the denominator. So let's list them. Numerator, 3x minus 7. Numerator prime, 3. Denominator, x times 5x plus 6. And I suppose in this case, instead of doing the product rule, just multiply out 5x squared plus 6x. Okay. We also could do, first derivative second plus second derivative of the first. Okay. But since this is already involved in a quotient, I think it's just as easy to multiply it out. Now, as I have recommended prior to this, use the product rule when you have a binomial times a binomial and don't fold it out. You need some practice with this formula right here. All right, now I've got to find d prime, 10x plus 6. So my c bar prime of x is my denominator, 5x squared plus 6x, times the derivative of my numerator, 3, and then that's going to be minus the numerator, 3x minus 7, times the derivative of the denominator, 10x plus 6, and then all of this, I'll just put brackets around it just to show that all of that is over our denominator squared, so 5x squared plus 6x squared. So our c bar prime of x is our denominator, 5x squared plus 6x. So that's our denominator. Now we need to do the derivative of the numerator, which is 3, minus our numerator, 3x minus 7, times the derivative of the denominator, 10x plus 6. And all of that is over the original denominator squared, so 5x squared plus 6x all squared. Okay. Now if you leave it as x, 5x plus 6, you got to square the x and that. Okay, and it would still be correct if you did that. All right, so now I'm going to distribute the 3 backwards to get 15x squared plus 18x minus, I'm going to fold this and then I'm going to minus it. Otherwise, I'm going to miss a sign. So fold it first. 30x squared is first. 18x is outside. Minus 70x is inside. Minus 42. All of that is still over 5x squared plus 6x all squared. So I've got 15x squared plus 18x minus, and I could have combined these two, but since I forgot to, I'm just going to go ahead and distribute, and then we'll combine them in the next step. So minus 18x plus 70x plus 42. Now notice that this positive here went to a negative, this positive went to a negative, this negative went to a positive, this negative went to a positive. That's because when this minus is distributive, all the signs get changed. All of that, don't forget, is over 5x squared plus 6x quantity squared. So combining our like terms, I get a 15x squared minus 30x squared. So that's a minus 15x squared. That's those two. And then I have an 18x and a minus 18x. So those are going to add to 0. But then I have a 70x. So it's going to be plus 70x. And then I have a 42 here on the end. So plus 42. All of that is over 5x squared plus 6x quantity squared. And so this is C bar prime of x. This is the average cost rate of change, the rate of change of the average cost. Now they did give us some more specifics. We're going to use this formula. Let me go ahead and write this marginal average cost function. And remember, marginal just means derivative. So that was negative 15x squared plus 70x plus 42 over that original denominator, 5x squared plus 6x quantity squared. Now the average cost for 20 means C bar of 20, and the marginal average cost means C bar prime of 20. So we start with this formula first because that's the average cost. So C bar of 20 is 3 times 20 minus 7 over 20 times 5 times 20 plus 6. And I could have distributed that x, but this will work. 60 minus 7 over 20 times 100 plus 6. So that's 53 over 20 times 106. So that's going to be 53. 20 times 106 is 2120. 53 divided by 2120 is 0.025. So we have to be really careful here and pay attention to one thing in our instructions. In hundreds of dollars. So this is in hundreds, so I have to multiply this times 100. Okay, and that ends up being 2.50. So $2.50 per unit. Now that's tricky, but if it's in hundreds of dollars, that means you have to multiply times 100 at the end. Now C bar prime of 20, okay, so we have to go down here to the C bar prime and do C bar prime of 20. So I've got a negative 15 times 20 squared, 70 times 20 plus 42. I'm going to type that in my calculator just like that. That's a negative 15 times 20 squared plus 70 times 20 plus 42. That's a negative 4558 divided by 5 times 20 squared plus 6 times 20 all squared. So again, I'm putting parentheses around it. I'm using the dot for times because parentheses and parentheses kind of get confusing. So parentheses, 5 times 20 squared plus 6 times 20, close parentheses, all squared is over 4,494,400. If I divide that out, negative 4,558 divided by 4,494,400, I get negative 0.0010. But again, it's in hundreds, so times 100 gives me negative 0.10. So that's losing 10 cents. Right? That's 10 cents. So up here, we're going to lose 0.10 or 10 cents per unit. Now, I say losing, but look, this is the cost. So our cost going down. So that's not a bad thing, like losing profit. Our cost is going down by 10 cents. Or you can write it 10 cents per unit at 20 units. So in other words, the 21st unit is going to cost 10 cents less to make than the 20th unit did.